Hi, so I'm posting this video as a way to show you guys the information that I need you to write down. So what we're doing is we're taking a look at our data that we collected in class last Friday. And so since I'm looking at 5th period's data right now, I'm noticing that our lowest point in terms of our distance, which is going to be on our y-axis, is going to be 0. And so I'm just going to go ahead and start 0 right here. Our highest point, which I think was won by Evan and Kaysen, is going to be 45.8. And so because I have 30 tick marks about up here, I'm just going to go up every 2. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. So each of these lines right here is going to then show us as having 2 meters. So it's going to go up 2 meters every line. So if we have at some point in between that, such as 5 for example, we would be halfway in between 4 and 6 on this x-axis here. The next thing we need to do is we need to figure out how many points we need here. For if you have numbers that are going to be less than 2 or 3, then I would say we should knock this off at about each of these lines being 0.1. We're still going to start at 0 for our x-axis, for our drag force, but we're going to go up increments of 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Here's where it gets a little bit tricky, because we have to get all the way up to, I think, 4.4 for our data. If I kept going this way, I would only be able to get about 3 of them in. And so what I'm going to do is I'm going to do 1.5 for the next one, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5. So as we get past 1, we're going to shrink it in size. This is a way of examining our data even if we only have a small amount of space to actually write with. And you can do this with any type of data and figure out how you want to shrink it. Unfortunately, I don't have a red pencil, so I'm just using a purple pen right now. Imagine este es rojo. Imagine este bolígrafo es rojo. Imagine this is red, please. Okay, so we said with our wobbly and straight that it's going to be, that wobbly is going to be rojo, or in this case faded purple, and then our other color is going to be the ones for stable. So the next step is actually graphing our data. Go ahead and flip back to your data table where you have all this information. Since we said that, okay, our wobbly is going to be red, or in my case purple right now, then what I want to do is I just want to go through and highlight all the ones that are blue. What this is going to help me do is just see which ones are blue and which ones I need to highlight in said blue. So I'm going through and I'm just highlighting all the ones that are going to be in blue. Any ones that are not in blue are going to be my other color, mi otro color. So our first one that we need to graph is going to be our group number 3. Hi, cat. Get up. With our group number 3, we're going to have our rocket distance being at 25. And because remember at 25 it is halfway between 24 and 26, that means it's going to be somewhere along this line. Our drag force is going to be 1.9. And so 1.9 is going to be somewhere here in our increment. It's going to be closer to the 2. And so we're going to go up, so where it was before, to 25.3, basically on the 19. So we're going to go ahead and draw a blue dot, un punto de azul aquí. We're going to draw one right there. We've gone ahead and done that once. Now we need to go through and do the rest of them. So I have 22, let's see, going all the way to 4.4. 11 and 1.1. 6.2 and 1.6. So we're going to be 6 on this line, and then 1.6 going up. And then this one should be pretty easy because we're on the 0 line, and it's going to be 1.9. Oh, but this one is wobbly, so we want to make sure that we do it in purple. Red. Es rojo. Este es rojo. Okay. Our next one is going to be wobbly again, so we are going to be at 2.6 or somewhat a little bit underneath halfway. And we're going to do 1.1. So we're going to go over here. Okay. And then we have another wobbly at 4. And that one is going to be 1.2, which is barely up there. As you can see, my pen is dying. We have some more wobblies, so 26.8. Since it's sort of about halfway between 26 and 28, a little underneath 27, we're going to put it a little underneath the halfway line here. And then we need to go over to 0.7. Something that I find helpful for graphing is that you use rulers to show you where across you're going and where up you're going. That way it helps you have your space, but when you are using a cell phone to film the other part, it's a little more tricky. We have 2 more wobbly points for period 5, so we're going to go to 17. And it's halfway between them, it's a little bit over. It's actually pretty close to 18. We go over to 1.2. With this 1.2, since it's between 1 and 1.5, it's going to be about halfway in between. We go up once again to 17. And then we have 0 at 1.5. Finally, with our farthest distance, we have 45.8, pretty much at 46, a little underneath that. And this one is at 0.4. 0.4. So taking a look at our data, there's some things I want you to notice. We're going to have take a look at where we have our wobbly versus stable. Do we see stable higher, having a higher distance, or do we see wobbly having a higher distance? Maybe we don't want to include this data point right here because although it was wobbly, it was very high up. Maybe that disproves our theory or ideas about this. The other thing that we need to figure out, we go over our questions, is we have to ask us for question number 2, was your prediction right or not? Why or why not? You need to have examples with this. The next question for number 3 is what is the actual drag force we calculated in the wind tunnel? To find this, you're going to convert from grams to kilograms. The way we calculate grams to kilograms is we're going to take our number of grams and divide by 1,000. So, gramos divided by 1,000. For number 4, it recommends including a diagram. Wink, wink, hint, hint. Please give me a diagram. If you do not give me a diagram, you're probably not going to be able to answer the questions and do well on this. These questions need to be written in blue or black ink or typed up. If you are writing it by hand, it must look neat. You've got to make it look good. Remember, this is worth as much as a binder check. Please write in full sentences, otherwise you will be marked down. You have until Friday, March 1st to complete this assignment. Staple on this extra paper using the left-hand corner. You need to make sure you have filled in any spaces in the rest of your assignment, right, in your redesigned. Please send me any emails if you have any questions. Let me know what I can do to help, and I will see you all on Wednesday. Goodbye.